Welcome to our video, Unveiling the Top 10 Climate Discoveries. Today, we'll take a deep dive into groundbreaking research that sheds light on our planet's most pressing environmental changes. From the secrets hidden in ice cores to the critical role of oceans and forests, we'll explore the significant findings that reveal the intricate connection between human activity and climate change. Join us as we uncover these vital discoveries that shape our understanding of the world and its future. 1. The power of ice cores. Ice cores are like time capsules that hold the secrets of Earth's past climate. Scientists drill deep into glaciers to extract these cylindrical samples, revealing layers of ice that have accumulated over thousands of years. Each layer traps tiny bubbles of ancient air, giving us clues about past atmospheric conditions. By analyzing these cores, researchers have discovered patterns of climate change, including ice ages and interglacial periods. This information helps us understand how natural factors influence climate over millennia. Ice cores are crucial for predicting future climate changes and developing strategies to mitigate their impacts. 2. Oceans. The unsung heroes. Oceans play a vital role in regulating Earth's climate, acting as massive heat sinks and carbon dioxide absorbers. Recent discoveries have highlighted the importance of ocean currents in distributing heat around the planet. These currents, like the Gulf Stream, influence weather patterns and temperatures globally. Scientists have found that changes in ocean circulation could lead to abrupt climate shifts, affecting ecosystems and human societies. Understanding the complex interactions between oceans and climate is essential for accurate climate modeling and forecasting. The ocean's role as climate stabilizers underscores the need for their protection and conservation. 3. Greenhouse gases. The invisible threat. Greenhouse gases, such as carbon dioxide and methane, trap heat in the atmosphere and contribute to global warming. Recent studies have shed light on the sources and impacts of these gases, emphasizing the need for urgent action. Human activities, like burning fossil fuels and deforestation, have significantly increased greenhouse gas concentrations since the Industrial Revolution. The discovery of methane emissions from melting permafrost and wetlands highlights the potential for feedback loops that could accelerate climate change. Reducing greenhouse gas emissions is crucial to limiting global temperature rise and avoiding catastrophic consequences. 4. The melting of polar ice. The polar ice caps are shrinking at an alarming rate, with profound implications for global sea levels and climate systems. Satellite observations have revealed the rapid melting of Arctic sea ice and the thinning of the Greenland and Antarctic ice sheets. This loss of ice contributes to rising sea levels, threatening coastal communities and ecosystems. Scientists have discovered that the melting of polar ice also affects ocean circulation and weather patterns, potentially leading to more extreme weather events. Monitoring and understanding polar ice dynamics is essential for predicting future climate impacts and developing adaptation strategies. 5. Forest carbon sinks. Nature's air purifiers. Forests are natural carbon sinks, absorbing carbon dioxide from the atmosphere and storing it in trees and soil. Recent research has highlighted the critical role of forests in mitigating climate change. Scientists have discovered that certain forests, such as the Amazon rainforest, are reaching a tipping point where they may become carbon sources instead of sinks due to deforestation and climate stress. Protecting and restoring forests is essential for maintaining their carbon storage capacity and preserving biodiversity. The discovery of forest carbon dynamics underscores the need for sustainable land management practices and conservation efforts. 6. Permafrost thaw. Unleashing ancient carbon. Permafrost, the frozen ground in polar regions, contains vast amounts of organic carbon. As the climate warms, permafrost is thawing, releasing greenhouse gases like methane and carbon dioxide into the atmosphere. Scientists have discovered that permafrost thaw could accelerate climate change by creating feedback loops that amplify warming. This process has significant implications for global carbon budgets and climate models. Understanding permafrost dynamics is crucial for predicting future climate scenarios and developing strategies to mitigate its impacts. The discovery of permafrost thaw highlights the urgency of addressing climate change to prevent irreversible consequences. 7. Coral reefs. Climate change. Coral reefs are highly sensitive to changes in ocean temperature and acidity, making them important indicators of climate change. Recent studies have shown that rising sea temperatures and ocean acidification are causing widespread coral bleaching and mortality. This loss of coral reefs threatens marine biodiversity and the livelihoods of millions of people who depend on them. Scientists have discovered that some coral species may adapt to changing conditions, offering hope for reef resilience. Protecting coral reefs requires reducing carbon emissions and implementing conservation measures to safeguard these vital ecosystems. 8. Extreme weather events. A new normal climate change is increasing the frequency and intensity of extreme weather events, such as hurricanes, heat waves, and floods. Scientists have discovered that rising global temperatures are fueling these events, leading to more severe impacts on communities and infrastructure. Understanding the link between climate change and extreme weather is essential for improving disaster preparedness and response. Recent research has highlighted the need for climate-resilient infrastructure and adaptive strategies to mitigate the risks associated with extreme weather. The discovery of these connections emphasizes the importance of addressing climate change to protect lives and livelihoods. 9. Acidifying oceans. A growing concern. Oceans absorb about a third of the carbon dioxide emitted by human activities, leading to ocean acidification. This process reduces the availability of carbonate ions, which are essential for marine organisms like corals and shellfish to build their skeletons and shells. Recent discoveries have shown that ocean acidification is progressing faster than previously thought, threatening marine ecosystems and food security. Understanding the impacts of acidifying oceans is crucial for developing strategies to protect marine life and coastal communities. The discovery of these changes underscores the need for reducing carbon emissions and promoting sustainable ocean management. 10. Climate models. Predicting the future. Climate models are essential tools for understanding and predicting future climate changes. Recent advancements in climate modeling have improved our ability to simulate complex interactions between the atmosphere, oceans, and land. Scientists have discovered that incorporating more detailed data and processes into models enhances their accuracy and reliability. These models are crucial for assessing climate risks and informing policy decisions to mitigate and adapt to climate change. The discovery of improved climate models highlights the importance of continued research and collaboration to address the challenges posed by a changing climate.